Good day, students, and welcome to today's class. In today's class, we're talking about the units of rate constant K. Okay, let me add a K here. Now, we know already in previous videos that we have what we call order of reactions, okay? And I spoke about three orders of reaction. I spoke about the first order reaction, the first order, okay? We talked about the second order, and we talked about the zero order. Okay, now for the first order reaction, or for a first order reaction, given that we have a reactant like this where A to give B, so the rate law expression R will be equals to K conc of A raised power 1, since this is the first order reaction. Similarly, if I have the same reaction, A to give B, my rate R will be equals to K conc of A raised power 2, since the second order. While for a zero order, if you have the same reaction, A to give B, R will be equals to K conc of A raised power 0 as a zero order. So from here, since I'm looking for the unit of K, let's make K subject of formula, okay? So divide both sides or multiply both sides by 1 over conc of A. We're going to be having K, sorry for that. We're going to be having K to be equal to what? R over conc of A. Okay. Now, don't forget, what's the unit of R? R is rate, right? Which is molar per second. So this is molar per second. All right. Then all over the unit of concentration of A is in what? Is in molar. So if you simplify, K here will be equals to molar per second times 1 over molar. 1 over molar. Okay, let me break that down. Here, this sign, this here, represent division. So this is divided by molar over 1. Okay, so what's it going to give me? So K will be equals to molar per second. So when division turns to times, this will go up and this will come down. So we're going to be having 1 over molar. So when molar cancels out molar, what do we have left? We have our K to be equals to 1 over seconds, or per seconds. Okay, so this is the unit of a first order reaction. So let's go back and see the unit for a second order reaction. Similarly, let's make K the subject of formula. So making K subject of formula, I'll divide both sides by conc of A square over conc of A square. So this cancels out this. What's our K? Our K will be equals to R over conc of A square. Okay, so the unit of, let me put this here. So K will be equals to, the unit of R is what? Molar per seconds. All over the unit of A is molar, but we're having square, so that will give me molar what? Molar square. So from here, our K will be equals to molar per seconds divided by what? Molar square. So our K will be equals to molar per seconds times 1 over molar square. So molar cancel one of the molars here. We still have 1 molar here, okay? So our K now, that's the unit for our K, rate constant K, will be equals to 1 over molar times S will give me molar seconds. So this is the unit for the rate constant, or I can write this as per molar per second. So this is the unit for the rate constant of a second order reaction. Now up to the zero order reaction now. Similarly, we do the same. Okay, we do the same thing. Yeah, so we divide both sides. But don't forget that all this, let me circle that, let me highlight it. All this here is 1. So I can write this as R equals to K. Wow. So that means K is also equals to R. And what's the unit for R? The unit for R is what? Molar per seconds. Molar per second. So the unit of rate constant K for a zero order is molar per seconds. The unit of rate constant K for a second order is per molar per seconds, while the unit for K for a first order reaction is per seconds.